Lesson 7.8. Without expanding, what's the coefficient of x to the fourth in the normal form? So all I care about is x to the fourth. So this guy, I care about it, and I don't want to expand this. So I have, but let's see if let's make an expansion box to see if. So we have x squared plus 3x squared. Well, that's right there. That's 3x squared, 4x squared, isn't it? So let me just combine that. That'll be easier. So I have 4x to the second power plus 1, and now I have 2x to the fourth minus 3x to the third plus 5x plus 2. And draw the line. And I don't really have to, I don't care about this one because this will be x to the 6th power. I care about this part. I don't care about this part because this will be 5th power. I don't care about this part because that will be 3rd. I don't care about this part, this part, this part, this part. So all I care about is this. This will be 2x to the 4th. So I am adding 2x to the 4th plus this 2x to the 4th. So that would be what? Right. Well, I almost did the entire answer, but yeah. The coefficient of x to the third in the normal form of polynomial below is 18. Right here. What's the coefficient of x to the third in the normal form of it? So x to the third, I got negative 13 here. Okay, so I got right here, I got negative 13. No, negative x to the third power. So I am adding some number right here. I don't know what that is. I don't even want to do it. But after you do it out, so I've got some number of x to the third from here plus negative x to the third right there equals, I've got 18x to the third power because that says that here. The coefficient of x to the third is that. So once we get that, if we can find what that is, well, I'm sure you know it by now. What would be the same thing? The only difference between this sentence and this sentence is just the operation right there. So the same exact coefficient times x to the third power minus negative x to the third. That would be what times x to the third power? This is pretty easy, at least to me. What's the coefficient of x to the fifth in the normal form of x plus 1 to the x to the fifth? So here's some hints. So let's say the first thing you need to do, well, first thing you need to understand is x plus 1 to the 5th power means you have 5 copies of it. So you have 5 copies of x plus 1. Okay? Now I would do this first by doing x plus 1 and x plus 1. Right? And the combined like term will fill out the, complete the table, and combined like terms you get something. That's gonna be the same as this part. Okay, well, I need one more. Okay, because this and this will be exactly the same. So once you get this, you do expansion box this times that, and then fill out the expansion table and complete it. You know, combine like terms. You get something, and then you do expansion box with this. Okay. Find the coefficient of x, y, z in the expansion form. Okay, this looks like a lot of problem, but it's not that bad. So we'll have x plus y plus z, and we have x squared minus xy plus y squared minus xy, xz minus yz plus z squared. Okay, let's do the let's find out which box we need to fill out in order to find the coefficient of xyz. So all we want to have is xyz. Right here, do we get xyz here? No, we don't. How about here? No, right? Because that's going to be negative x squared y, so we don't care about this. We don't care about this. We don't care about this part, but we care about this part because that's going to be negative xyz. And we don't care about this part. So this is what you need to do for the next row and this row. Find out which one has xyz and combine like terms. So right here, this will be negative xyz. That means negative 1 xyz. So the coefficient will be negative 1. And find those coefficients so that you can add it. Or 16, standardized test prep. The coefficient of x to the fifth is the normal form of that is the number of way you can roll a sum of 5 to number cubes. What's the coefficient of x to the fifth in the normal form? What's the coefficient of x to the fifth power? Here. Actually, there's a mistake here. I'm sure there is a second power right here. Okay, and if you remember this similar problem from 7.6, I believe, you can take a look at the notebook. I'm sure you have the table, and you don't have to reinvent the wheels. If you look at the table, you already have that table. So I want you to look at those. 17. Ed Burbu, a mathematician from Toronto, writes the following three equations. 1 plus 2 equals 3, 4 plus 5 plus 6 equals 7 plus 8, 9 plus 10 plus 11 plus 12 equals 13 plus 14 plus 15. Wow. Describe the pattern. What do you notice? What's the next equation in the series? Make some conjectures. What can you prove? Wow, that's a lot of problem. But this is a very interesting problem, and this is one of the beauty of mathematics comes in. So enjoy this.